Okay, today we are going to do 9-3 binomial expressions. So we're going to start at, okay, so in algebraic terms, if I have some number multiplied by a certain root, and I want to add that with some other number multiplied by the exact same root, I can do that as long as they are like radicals. So how do I go about that? Well, the numbers on the outside I can add, and the root stays the same. So if I want to subtract, same thing. So whether this is adding or subtracting, let's do that in blue. I can add or subtract the outside numbers, but the root stays the same. So let's try some examples of this. So let's say we have 3 times the square root 5x minus 2 times the square root 5x plus 6 times the square root 5x. So how are we going to go about simplifying? Well, let's start at the radicals. We have root 5x, root 5x, root 5x. Are they like radicals? Yes, they are. So since they are like radicals, I can keep that root 5x, and I can simply take the numbers on the outside and do the correct operation. So I got a 3 on the outside here. I have a minus 2, and I have a plus 6. So 3 minus 2 is 1. 1 plus 6 is 7. So I end up with 7 times the square root of 5x. And we're done. So let's try another one. What if we have a 6x squared square root 7 plus 4x square root 5? Can we simplify this? So look here, do we have like radical, root 7, root 5? Nope, they're not the same. So not the same, not same. So because they're not the same, we can't simplify. So you can't simplify, you're done. That's as small as we can get it. 6x squared root 7 plus 4x root 5. So let's try another one. What if we have 8 times the 5th root of 7xy minus 12 times the 5th root of 7xy? Do we have like radicals? Well, 5th root 7xy, 5th root 7xy. Yes, those are the same. And all we got to do is take the outside numbers. 8 minus 12. What is 8 minus 12? 8 minus 12 is negative 4 times the 5th root of 7xy. And we're done. So let's take it up a notch now. Let's look at this one. What if we have 3 times the cube root 81a minus 2 times the cube root 54a? So let's start with, are they like radicals? So cube root 81a, cube root 54a, uh-oh, they're not the same. But let's see if we can break it down. 81, that's a rather large number. Let's look if this is a cube root. Is there a different way I could rewrite this? And there is. I can rewrite 81 as 27 times 3. So let's rewrite that. I still got a 3 on the outside, but now I can instead rewrite it as 27 times 3 times a. Well, let's see if we can do the same thing with the 54. So 54, let's see, what numbers can we multiply to get us 54? That is a perfect cube. And 27 works there as well. This is 27 times 2. So we can rewrite 54 as 27 times 2. Again, we're not changing anything. It still equals 54. We're just writing it a little differently. And let's see if this helps us. So let's see if we can simplify. So now that we have 3 times the cube root, 27 times 3, well, cube root of 27, that's a perfect cube. I can boot that to the outside. Cube root of 27 is 3. And the 3 and the a still stay on the inside. And cube root of 27, again, cube root of 27 is 3. So I can take the cube root, put that on the outside. And 2a stays on the inside. So simplify, we have a 3 times a 3 on the outside. 3 times 3 is 9. And we got a 2 times 3 is 6. And we look at our radicals. A 3a and a 2a, those are not alike, so I cannot do anything else. I am done. That's as small as I am going to be able to get it. Not too bad. So let's try this one. What if we have square root 12 plus square root 75 minus square root 3? Again, our goal is to get it as small as possible. So let's see if we can break down those large numbers. So 12, square root of 12. Well, 12 is not a perfect square. But what can we multiply to get 12 that is a perfect square? We can rewrite 12 as 4 times 3. 75. 75 is not a perfect square, but we can multiply 25 times 3 to get a 75. And 3 is prime, so that's just going to stay there. But let's see, how does this help us? Square root of 4, ding, ding, ding. 4 is a perfect square. Square root of 4 is 2, so that 2 can go on the outside. 3 has to stay on the inside. Here, square root 25, ding, ding, ding. Square root of 25 is perfect square. That is 5, so 5 can go on the outside. And again, 3 has to stay on the inside. Well, look, what do we have now? Root 3, root 3, root 3. They are like radicals. So I can simplify into just using one root 3 by taking the numbers on the outside. So what numbers do I have on the outside? I have 2 plus 5. And I don't have a number here, which really means there is 1. So 2 plus 5 is 7, minus 1 is 6. So root 12 plus root 75 minus root 3 simplifies to 6 square roots 3. So that is simplifying by adding, subtracting binomial expressions or radicals. So now we're going to multiply different binomial expressions. So binomial, again, root by means 2. So we're going to be taking 2 terms and multiplying by 2 terms. So let's look at an example. How are we going to go about multiplying 3 minus square root x times 5 plus square root x? Well, anytime we have a binomial times a binomial, yes, we're going to multiply. Multiply here really does mean FOIL. And what I like to do with FOIL is I like to draw a box. So I'm going to draw a box. Because I have a 2 by 2, I'm going to draw a 2 by 2 box. And I'm going to put the numbers on the outside. So I've got 3 here. I've got negative square root x here. I have 5 and I have root x. So now we can multiply. So if I multiply, the box tells me exactly what to multiply. 3 times 5 is 15. 3 times square root of x is 3 square root x. 5 times negative square root x is negative 5 square root x. Negative root x times root x. Root x and root x is just x, so this would be a negative x. So write out what we have. We have 15 plus 3 root x minus 5 root x minus x. And what I love about a box is notice your like terms are diagonal. So because we have the same radical root x, 3 minus 5 is a negative 2. And I don't have any other like terms, so we can max it. We are done. Let's try one more of this nature. What if we have let's say we have 4 plus 2 square root 2. And then 5 plus 4 square root 2. So again, I have a binomial times a binomial. That means I'm going to need to FOIL. If you like to FOIL without the box, that's fine. I like to draw the box. So since I have a 2 by 2, I'm going to draw a 2 by 2 box. I have a 4 here. I have a 2 root 2. I have a 5 and I have a 4 root 2. So let's multiply. Box tells me what to multiply. 4 times 5 is 20. 4 times 4 root 2. Again, multiply the outside. 4 times 4 is 16. Then I just keep the root 2. 5 times 2 root 2. Multiply 5 times 2 is 10. And we just keep the root 2. And 4 root 2 times 2 root 2. Multiply the outside. 4 times 2 is 8. And root 2 times root 2 is 2. So 8 times 2 is 16. So we write out our terms. We've got 20 plus 16 root 2 plus 10 root 2 plus 16. And what I love about the box, again, your like terms. I got 16 root 2 and 10 root 2. So I can add 16 plus 10 is 26 root 2. And I have another like term. 20 plus 16 is 36 plus 26 root 2. And we are done. So one last thing before we finish this lesson. So we subtracted some binomials, we multiplied some binomials. The last operation we need to do is divide. So let's see what division looks like. How do I divide binomial expressions? So with division, as always, often with division often means a fraction. Just like with i's, roots cannot stay in the denominator. So no square root can stay in the denominator. Can be in the denominator. No square roots can stay in the denominator. So we must multiply by what's called the conjugate. So conjugate, big fancy word, all it means is change the sign. And I will show you an example of that. So let's look at an example of that. So your division example. What if we have 3 square root 2x squared over root 5 minus square root 2. So our goal is to simplify this, get it as small as possible. So first, let's see, just off the bat, is there anything that I can simplify? Well, I have square roots here. Square root 5, that's not a perfect square. Square root 2, that's not a perfect square. 2 is not a perfect square, but square root x squared, that I can't simplify. What is the square root of x squared? Square root of x squared is x. So I can boot that to the outside and just keep the root 2. Okay, but now I'm stuck. And what did I just say up here? I am not allowed to keep a square root in the denominator. So I'm going to have to find a way to get those square roots out of the denominator. So what we need to do is we need to multiply by the conjugate. So conjugate means I'm going to look at the denominator, root 5 minus root 2. And I'm going to just change that middle sign. So I'm allowed to do an algebra. Whatever I do to the bottom, I can do to the top. So I'm going to multiply the top and the bottom by the exact same thing. So it's going to be 1, which is going to be a fancy one. But I'm going to take the denominator, root 5, and instead of multiplying by minus, I'm going to multiply by plus square root 2. And again, I have to do the exact same thing to the top and the bottom. Because again, this divided by bottom is still 1. I'm still multiplying by 1. It's just a fancy one. Okay, so I found my conjugate, root 5 plus root 2, going to multiply the top and the bottom by both. So how do I go about that? For the top part, I'm going to just distribute. So if I distribute the numerator, I have 3x root 2 times root 5. So outside multiply, inside multiply. So I got a 3x on the outside. Root 2 times root 5 is going to be root 10. And then 3x root 2 times root 2. I don't have numbers on the outside, so it's 3x. Root 2 times root 2 is actually square root of 4, which is 2. So this will eventually simplify to 3 times 2 is 6. So 6, let's see if I can squeeze it over there, 6x. Let's take a look at that denominator. Notice the denominator, I have a binomial times a binomial. Well, if I have a binomial and a binomial, I'm going to have to FOIL. So how do I FOIL? I like to draw a box. So I'm going to come over here and draw a box. I have a root 5 with a negative root 2. And I have a root 5 with a positive root 2. And the box tells me exactly how to multiply. So root 5 times root 5 is root 25, which is just 5. Root 5 times root 2, again, 5 times 2 is 10, so root 10. Negative root 2 times root 5, this would be negative root 10. Negative root 2 would be negative 2. So if I simplify what I have here, notice I have 5 minus root 10 plus root 10 minus 2. So, what do we notice about my middle terms? The middle terms are going to cancel. And we're just left with 5 minus 2, which equals 3. So my denominator here is just 3, which is very nice because, well, look at that. 3x divided by 3 is, the 3's cancel, so just x root 10. And 6 divided by 3 is 2x. So final answer would be x root 10 plus 2x. You might also see this written a little differently. I could also pull out that x and write it as a parenthesis root 10 plus 2. So just know that these are equivalent. One's not wrong or right. They're both correct, just you might see it written in different ways. So that is dividing binomial expressions. They're not allowed to keep a square root in the denominator. So what do you have to do? You got to multiply by the conjugate. Conjugate, fancy word for swap the sign.